Okay, we're going to do a proof by induction here, but we've got an inequality sign in the proof by induction. So we're going to start off as we normally do with proof by induction, and that's to take the first value of n, which in this case is 0, and just check that that indeed works. So 3 to the power of 0 greater than or equal to 1 plus 2 times 0, which is 0, and this here is 1. 3 to the power of 0 is 1, and that's greater than or equal to 1. That's true. So my next line, I want to assume n equals k is true, and that particular line, which is 3 to the power of k, is greater than 1 plus 2k, will be used later in our inductive step. So our inductive step is to let n be equal to k plus 1. Now I've got what, let me just write out what I want to get to with this step. I want to get to the fact that 3k plus 1 is greater than or equal to 1 plus 2 brackets k plus 1. And if we just expand that bracket out, because this might help with our final proof, we want to prove that it's 3, that should be 2k plus 3 in here. So I'm just going to keep an eye on where I want to get down to, which is 3 to the power of k plus 1 is greater than or equal to 2k plus 3. Now, I can write 3 to the power of k plus 1 that's the same as 3 to the power of 3k. And 3k, I'm now going to make use of, I'm going to say that this has to be bigger than 3 times 1 plus 2k. So 3k is greater than or equal to 1 plus 2k. That was our assumption here. And if I multiply them both by 3, where k is greater than or equal to 0, this will always hold true. So now I've got on this side 3k plus 1 is greater than or equal to 6k plus 3. Remember, what I'm trying to actually prove is that 3k plus 1 here is greater than or equal to 2k plus 3. Now I know that 6k plus 3, that's bigger than 2k plus 3, which is up here. So why don't I replace this bigger value with a smaller value? Because if this is bigger than this, it has to be bigger than this. And this is what I was trying to prove. So as this proof, as it holds for n equals k plus 1, it is true, or it holds for any value of n.